535 मार्क्स।
बस थोड़े से मार्क्स से रह गई। बायोलॉजी ठीक था, केमिस्ट्री भी, पर फिजिक्स वो फिसल गया। इस बार पढ़ाई नहीं, तैयारी करो, वो भी स्मार्ट तरीके से, क्योंकि इन्फिनिटी लर्न लाए हैं अट्रेया, इंडियाज मोस्ट पावरफुल नीट रिपीटर्स प्रोग्राम विद P² CB, जिससे फिजिक्स पे होगा डबल फोकस। डोंट जस्ट मेक इट योर लास्ट ट्राई, मेक इट योर बेस्ट वन येट। Join Infinity Learn today.
NEET 2025 didn't go as planned. 535 marks.
बस थोड़े से मार्क्स से रह गई। बायोलॉजी ठीक था, केमिस्ट्री भी, पर फिजिक्स वो फिसल गया। इस बार पढ़ाई नहीं, तैयारी करो, वो भी स्मार्ट तरीके से, क्योंकि इन्फिनिटी लर्न लाए हैं अट्रेया, इंडियाज मोस्ट पावरफुल नीट रिपीटर्स प्रोग्राम विद P² CB, जिससे फिजिक्स पे होगा डबल फोकस। डोंट जस्ट मेक इट योर लास्ट ट्राई, मेक इट योर बेस्ट वन येट। जॉइन इन्फिनिटी लर्न टुडे।
Hello, good afternoon, my dear students. Welcome to one more amazing session from Infinity Learn. This is Suresh, Faculty of Chemistry. Please confirm, can you all able to see me? Can you hear me? Those students who are online, please confirm, can you all able to see me? Can hear me? Okay, so today we are going to discuss about the most important and seems like most complicated theory in the chemical bonding, that is molecular orbital theory. And today I can guarantee you that this complicated topic is going to be as simple as it is possible. Can you believe it? Yes, of course, it is a simple topic for us. And let us talk about more details, because this molecular orbital theory, definitely whatsoever the competitive examination you are preparing, it is there, and one question will be asked based on this. And it is based on quantum mechanical approach of the molecular orbitals, how the orbitals are formed. So bachcho, here I just want to discuss here molecular orbital theory. Before going for the molecular orbital theory, I just want to show you Atreya program. So what this Atreya program tells you? This Atreya program tells you India's most amazing program, and that is designed for NEET repeaters. And this program is making you to, when you going for a drop for an year for NEET examination, will make you the situation from I didn't do to I will do it. Yes, it is true. And crack your NEET examination, Sri Chaitanya Academy of Infinity Learn is going to introduce you Atreya program, India's most powerful NEET repeaters program. And the link is available in the description box. You can click it and you can enjoy it. Dear, and the details about this, it is going to be Atreya program. It is a revolutionizing program where you can see the P² CB program, double the preparation for your physics and along with your chemistry and biology. When you go with the examination with the NEET 2025, you have the biology, it was good, and chemistry okay, and when it comes to the physics, it is slapped like anything. So Infinity Learn, our team is going to come up across with these problems, and it is not your problem, it is every student's problem. The physics is going to be a nightmare for your preparation. So we want to come out this program by using a P square CB program where you are going to give the double practice for the physics. So, practice always only the way to get out of a problem. So, for that I just want to introduce you these program details here. The batch commenced from May 23 and every week new programs are given, new batches are getting introduced. So, for that you can have, if you enroll, you are going to join in a new program and a new batch as well. Okay, so you are going to have the sessions from Monday to Saturday, and in this every day you are going to have 3 classes, 2 concept classes, 1 practice session, and each session is going to be 90 minutes, 1 hour 30 minutes. But so here you will be having classes per week, 18 classes per week. In this 18 classes per week, you will be having definitely double practice class for physics, and there lies the secret of the infinity length P square CB program. And you can see there are 465 classes, the live interactive sessions, and also 240 DPPs will be given throughout the program, and dedicated practice session 120 sessions will be there, and in that physics practice session is going to be double practice session, and also after class revision notes will be given in the PDF form automatically, and batch size for the practice is going to be 20 to 25. This is very important. When you have this practice 20 to 25, a limited number of students will be given, so that you will be having a chance to interact with your faculty, senior faculty, so that a customized doubt resolution will be there. Believe it, it is a very good program, and also coverage of the total 11th and 12th syllabus will be there. So this is an awesome program. You just check it once or click and just pursue the course, and you are going to really feel it is amazing and awesome. Bacho, and this is the promotion is done from my side. If you do NEET examination well, I strongly recommend you just click this link available in this NEET 2025 rank predictor and seat predictor, and for once you got the rank, and when you enter your details, you will be getting which college and which course, and counseling guidelines will be given. And my promotion is over, Bacho. Now let us talk about the molecular orbital theory. So, features of molecular orbital theory, it's very important, dear children. And actually when you start with chemical bonding, you start with ionic bond, covalent bond, VSEPR theory and VBT, everything is going good along with up to hybridization. Once you enter into the hybridization, the problem actually persists. So, what exactly the problem? Once you enter into the molecular orbital theory, there are certain things which cannot explain by the VBT, hybridization and whatever. Oxygen is a molecule which is a paramagnetic in behavior. Mean to say, if you take oxygen, put it in the external magnetic field, it is deflecting. But this deflection is not explained by valence bond theory. Valence bond theory, according to this theory, oxygen behavior is supposed to be diamagnetic. It has no magnetic properties at all, but it has a magnetic property. So, certain behavior of the molecules is not explained by VBT. So, that molecular orbital theory is introduced by quantum mechanical approach. So, what this quantum mechanical approach can tell you? This quantum mechanical approach tells you the combination of the atoms, mean to say the atomic orbitals. When the atomic orbitals combines, it gives rise a molecule, and so that molecular orbitals will be there. So, just like the electrons in the atomic orbitals, the electrons are there in the molecules, so that molecular orbitals. As you write the electronic configuration in the atoms, you are going to have the electronic configuration in the molecules. So, that is explained on the basis of molecular orbital theory. So, it is a lengthy process. Technically, I am going to explain you the lengthy process, but also I am going to give you the simple awesome tricks, so that so complicated process is going to be simple version you are going to attend it. So, please give me a thumbs up and fire emoji so that we can start the class. Bacho, yes. I want to know the students who are there in the right now, please like the session and share with your friends and subscribe to NEET Infinity Lens channel. Okay, come on, just a minute. Yeah, let's talk about the features of the molecular orbital theory, bachcho. In this molecular orbital theory, this is a atom and this is an atom and this is the nucleus and its electron cloud is seen like this, whatsoever the orbital may be. And when these two are combined, so what happened? The first feature is going to be electrons are associated in the molecule as a whole, not with individual atom. This is an individual atom. When the individual atom combines, is going to give rise a molecule, so that the entire molecule is together once, and you are going to see this is a molecular orbital. How this molecular orbital is seen, I just want to show you there. Bacho, in this feature 2, you know, the atomic orbitals of the individual atom combine to form a molecular orbital. This is your molecular orbital. आपका जैसे इलेक्ट्रॉनिक कॉन्फ़िगरेशन एटॉमिक ऑर्बिटल में है, उसमें इलेक्ट्रॉनिक कॉन्फ़िगरेशन मॉलिक्यूलर ऑर्बिटल में भी होगा, and that is going to be shown here. And feature 3, all the features of the postulates will be given according to linear combination of atomic orbitals, LCAO. So feature 3, energies of the atomic orbitals that are combined by LCAO, linear combination of atomic orbitals, supposed to be nearly the same energy. So then only they can combine and must be comparable, nearly the same energy. Bacho, you can see here. And how many molecular orbitals can be formed when the atomic orbitals are joined? Yes, number of atomic orbitals that are combined should be equal to the number of molecular orbitals that are formed. That is what is given. Number of molecular orbitals that are combined should be equal to number of combined atomic orbitals. AO should be equal to MO. AO indicates that atomic orbitals, bachcho. MO indicates the molecular orbitals. Here you can see and also you can see the 2 AOs produce 2 MOs. If 4 AOs combined gives 4 MOs, right? 2 plus 2. 2 plus 2 gives us 4, right? So 2 AO produce 2 MO, one with lower energy. 2 atomic orbitals combined. It should form 2 molecular orbitals, one with low energy, another one with high energy. Deepika Naidu, hi. And please like the session and please follow and take a note and notebook and write the outlines, not every point. Okay, Deepika? And the one with low energy orbital is called as bonding molecular orbital. Hi, Deepika Naidu. And the one with higher energy is called anti-bonding molecular orbitals. Okay, Anjana, good morning here. Hello, Deepika. Hello, and good morning, Anjana. Paul, yes, good morning. Right, let's talk about, if you see, when you see the formation of the 2 atomic orbital combined gives rise a molecular orbital. So 2 atomic orbital combined to form a molecular orbital. There are 2 types of molecular orbital. One is bonding molecular orbital, which has more electron cloud between the bonded atoms. While there is a less energy, less electron cloud between the bonding atoms. Therefore, you can see a node, that is what is called as anti-bonding molecular orbital. So the bonding orbital has more stability and less energy. Anti-bonding orbital has more energy. Hi, Anjana Pal. Any doubt? You can use the chat box. It's a live interactive session. I want to see that you are there in the class and your understanding. Okay, very good, nice. Let us continue in this contribution. Okay, Anjana Pal, you just click the like button so that your click is going to be visible to me, so that is going to be the interface. And you can see feature 4. And it is going to be types of molecular orbitals. As I mentioned, it is going to be 2 types. One is bonding molecular orbital, another one is anti-bonding molecular orbital. How bonding molecular orbital is formed? Because the atomic orbital is a wave. So 2 waves are combining because 2 atomic orbitals are combining. When 2 waves are combining, they can combine by using a destructive interface or by constructive interface. Destructive interface is going to have less electron cloud, anti-bonding, and constructive interface you are going to see this bonding molecular orbital. That is explained here. BMO, bonding molecular orbital, has more electron cloud with it, so it is less energy and more stabilized. Okay, and talking about anti-bonding molecular orbital, it has less electron cloud between the nuclei and it is going to be more energetic, virtually it is going to be less stable. So, bonding molecular orbital stabilizes, anti-bonding molecular orbital destabilizes. Anjana Paul, okay, fine. Deepika, are you there in the live? Okay, those who are there in the live, please, you can ask any kinds of doubts. Let's talk about the linear combination of atomic orbitals. This is explained by simple LCAO, linear combination of atomic orbitals. It talks about the wave functions here. So, wave x, atom ka x and y combine to gives rise a molecule. So, atom x का wave ऐसे होगा, atom y का wave ऐसे होगा. So, x and y can combine to gives rise a new wave. This new wave can be formed by two ways. One is a destructive method, another one is a constructive method. So, when it is going to have when A and B are atoms are combined, see here carefully, combining wave functions are in the same phase. If it is in the same phase, it is going to get the wave, psi is going to be wave function, bachcho, wave function, that is amplitude wave function. It can combine psi A plus psi B. When psi A and psi B is combining, it in addition is taking place. The addition of wave functions is called a constructive wave function. It gives rise bonding molecular orbital. Clear? That gives you this atom and this atom combine. इसका wave जुड़ा के इसका molecule बनेगा. So a molecule में more electron cloud is can be seen. So it gives rise bonding molecular orbital. This is your bonding molecular orbital. Understand? So it is going to have a less energy. While you are talking about electron density in BMO and ABMO, electron density increases in the internuclear region for this bonding molecular orbital. So it is going to be psi square is additive function. It is going to be additive function. Deepika Naidu, come on. And at the same time, you can say this is what is called as a BMO. It is going to be addition. Psi A and psi B दोनों add करना है. ठीक है बेटा? And you can say linear combination में ABMO, it is anti-bonding molecular orbitals. This is formed by destructive interface of the atomic orbital waves. So it is see this can be formed where A and B are atoms combined. Two waves are combined in the destructive interface. That is going to be psi A minus psi B. That is not a plus, that is going to be minus. So it is going to have, when subtraction takes place, it is going to be psi A is subtracted with psi B. So that the two waves join together in the different phases, they are going to destroy. When they destroy, the electron cloud go beyond the nucleus of the bonded atoms ताकि इसका node बीच में मिलेगा. What is the meaning of a node? बच्चों, I want to hear from you, what is the meaning of a node? Node is the place or a region or a point where the probability of finding of electron is going to be 0. अगर electron हो, yes, electron नहीं हो. Electron है इसका orbital बोलना, electron nahi hai iska node bolna. Understand? Clear? Now let us say electron density and BMO and ABMO. So it is going to be ABMO. Electron density is 0 here. So this is what is called as a node. This is what is called as a node. So this is formed by, this is what is called as a node. And this is called as psi A minus psi B. This is what is called as a psi A minus psi B. ठीक है? And this is anti-bonding molecular orbital. अरे नीट एग्जामिनेशन में MCQ काटने का इतना डेप्थ में नहीं जाना, But as a formality sake, I just want to explain you the thing. You don't have to worry about this. Dear children, find any doubt, you please let me know. Please let me know. If you have any doubt, please let me know. Now you can see types of molecular orbitals. So what is the type of molecular orbital? When atomic orbital combines this bonding molecular orbital, anti-bonding molecular orbital. So look, लगता है आपको पीटी क्लास चल रही है क्या, पीईटी क्लास? So like this सर कुछ कर रहे हैं ना? Yes, you just learn like that. In the examination also, the same image should be there in your mind, so that you can recall what exactly teacher wanted to say, what exactly the question is demanding. So you are all attending this YouTube class for the sake of learning molecular orbital theory and cracking NEET examination, whatsoever the competitive examination may be. So which require involvement. That involvement comes really from these good classes. So here all from YouTube channel, from the Infinity Learn, the expert faculties are explaining you thing, real time content. It is not like a glamour show. So take this advantage and please like this session and share with your friends and like and subscribe to Infinity Learn NEET YouTube channel. And these sessions are absolutely free of cost. That's the reason why students, please use these sessions. To get this kind of sessions, you need to pay a huge amount of money in the coaching industries and you have to travel along, and these are all completely simple and you can sit at your home and you can crack your NEET examination. You may feel that yes, YouTube classes में attend करेंगे तो NEET निकलेगा, अरे you can get it. You can be a topper as well. Believe me, it can have. You can be a topper from the YouTube lectures in the 2024 and 2025. I have dozens of students who attended this NEET 2024 and 25 who have the toppers in that. Believe it, it is done. And it also say you have bonding state, electron cloud ज़्यादा दिख रहे हैं, and anti-bonding state, electron cloud कम दिख रहे हैं. So I just want to say bonding state में molecular orbital ऐसे दिखता and anti-bonding molecular orbital cloud spectroscopy में ऐसे दिखता. So you are going to see a node between these two, understand? And of course in the shapes of MO and 2pz and yes, I just want to show you s orbital. Yeah, s orbital को दिखा है ना? हाँ. We have sample questions as well for today, and I just want to show you how linear combination of atomic orbitals are shown. Simple thing you can say. Anjana Paul, Naidu, you just follow this. So according to LCAO, look at this. This is the energy scale, bachcho. This is the energy scale, okay. And when atomic orbitals are combined to give rise its molecular orbital, you can say here it is going to be atomic orbital. So violet you cannot see, and atomic orbital and molecular orbitals. So when you say here it is an atomic orbital of similar energy is going to combine to give rise molecular orbital. Okay, this is about the molecular orbital. So this molecular orbital of two cases, one is bonding molecular orbital, another one is anti-bonding molecular orbital. You see, first lowest energy is going to be 1s orbital, okay, is combining with 1s orbital of another atom. So it is going to give you two types of orbitals, that is called as sigma 1s orbital and sigma star 1s orbital. So bonding molecular orbital, anti-bonding molecular orbital. So anti-bonding molecular orbital is shown by a star, okay, and you can say 2s orbital and 2s orbital combine to give rise sigma 2s, and you have sigma star 2s, sigma star 2s. Now 2p orbital has px, py, pz. So that you are going to see px, py and pz. Px, py and pz is combined to give rise with another px and py and pz. You are going to see the formation of doubly degenerated orbital. It comes like this here. So 2 orbitals down and you are going to have 2 orbitals up. Excuse me. So when 2 orbitals down, this is going to be sigma 2pz and pi 2py, pi 2pz, 2px, and you have pi star 2px and pi star 2py and sigma star 2pz. So this is the energy. So lower energy orbitals, then higher energy orbitals. So while filling these electrons in the atom, you follow Hund's rule, Aufbau rule and Pauli's rule. Similarly, while filling the electrons in the molecular orbitals, you fill these orbitals in the order of the Aufbau and Hund's and Pauli's exclusion principle. And let us see how p orbitals are going to combine. That is what to show you. And these are all 2 categories, up to nitrogen, up to 14 electrons, after 14 electrons. Many things are there. I want to show you with a lot of tricks as well. Stay tuned, my dear bacho. Okay, you can see combination of the orbitals. So manually I have shown. Now let me show you the detailed version of this. Now shapes of molecular orbital of sigma 2pz. In the sigma 2pz, so this is the z-axis, pz orbital combines to give rise in phase. You are going to get a sigma 2pz orbital. So this is the nucleus and this is the nucleus, and this is going to be more electron cloud is going to be accumulated between 2 atoms. That is what is called as bonding molecular orbital. And moving ahead, if it is a star sigma 2pz, if plus and minus combine, no destructive interface takes place. In this destructive interface, you are going to have a nodal plane that is called sigma star 2pz. And also shapes of pi orbitals you can say. So 2px and 2py, you are going to see these lateral overlapping between 2. You're going to give you in phase, you're going to see this sigma 2pz. So px or py, anything can happen. Okay, px or py, anything can join. And you're going to see a nodal plane here. One nodal plane is there between that px and antibonding orbitals. And you can have and bonding orbitals and antibonding orbitals. You are going to have 2 nodal planes for the p orbitals. So this is what is called as the nodal plane. So for that bonding pi orbital, 1 nodal plane is there, anti-bonding orbital, 2 nodal planes are there. You can see this is a nodal plane, you can see another nodal plane here. Understand? Clear? And also you can see the combination of atomic orbitals must have the same energy or nearly the same energy. That is the essential condition. That is the essential condition for bonding. When you see this bonding here, condition for LCAO, and multiple choice questions can be extracted from this conditions for LCAO. And here the combining atomic orbitals must have the same symmetry about the molecular axis. They should have the same energy, that is one condition, and they should have the same symmetry as well. One is joining like this, yes it is. Another one is joining like this, it is also permitted. One orbital is like this, another orbital is like this, is not at all permitted. Anjani, okay, and you can see quick contrast, you can see bonding orbital and anti-bonding orbital. These are the noteworthy points that can help you. In the bonding orbital may or may not have the nodal plane, but anti-bonding molecular orbital always have a nodal plane. What is nodal plane? I already mentioned. अगर इलेक्ट्रॉन है ऑर्बिटल, इलेक्ट्रॉन नहीं है नोड और नोडल प्लेन, जहां पर जिस प्लेन में इलेक्ट्रॉन नहीं दिखता ये वाला नोडल प्लेन बोलना है. Avnik Rao, hello, good evening, sorry, good afternoon. So here it is represented by a sigma 1s, sigma 2pz, pi 2px, pi 2py, like that. Here it is represented by the same orbital with a star. If the orbital, molecular orbital has no star at all, it is the bonding molecular orbital category, low energy. If they have the star, they are come to the anti-bonding molecular orbital and has the more energy. Okay, so Avnik Rao, and please like the session. I just request you to just press the like button. Okay, take a note and write noteworthy points so that you can get the best out of it, right? Avnik Rao, come on. If you have any doubt, you can ask in the chat box. Now let us see here the molecular orbital diagram up to 1 to 14 electron system. It has pi electron should be filled first. After 14 electrons, pi electron should be filled next, so that sigma has to come. That is an exception over here. Now, thank you, Avnik Rao. So, energies of molecular orbital with greater than 14 electrons. If it is greater than 14 electrons, you are going to say 1s is less than star 1s, sigma star 1s is less than sigma 2s, sigma star 2s, and pi 2px and pi 2py are degenerate. They have the same energy and is less than sigma 2pz, and pi star 2px is equal to pi star 2py is less than sigma star 2pz. Okay, and you are going to see the difference here and here after 14 electrons. That is important. That is the trick. ये इलेक्ट्रॉन ऐसे आएगा, ये इलेक्ट्रॉन ऐसे आएगा, वो भी देखना चाहता हूँ. If it is energy level, it is an energy level diagram. It is a sequence, no? It is an order. It is directly written. If you memorize this order, you can do the best in your examination. So before this, I say electron wave graphs कुछ नहीं आएगा. These things will not come. Only if you memorize this, you can directly write the electronic configuration. Even that also I have a trick to explain you. Ready for that? Okay. Now, if you see the molecular energy diagram here, that manually I drew now, the same thing you are going to see. So, you can see the atomic orbital and atomic orbitals of similar energy of this going to give rise molecular orbitals. You can see atomic orbitals and 1s orbital combined, sigma 1s orbital, sigma star 1s orbital. This is combination of s orbital. Are you getting or not? Clear? Avnik Rao, any doubt? And Anjana Paul, what happen if p orbitals combines? So this is about 1s orbital and atomic orbitals. These are the atomic orbitals. These are the atomic orbitals gives rise to molecular orbitals, right? Now let us talk about 2p orbitals. You have px and py and pz, and you have px and py and pz. So this is your pz. So px तीनों बराबर देखना पड़ता है. So this come little up. Okay. So up to 14 electron बच्चों, this is going to be pi and this is going to be pi 2px, pi 2py. उसमें star नहीं देखना चाहिए, and it is going to be sigma 2pz. So it is going to be no star bonding molecular orbital, and it is going to be with star. It is going to be anti-bonding molecular orbital. So lower energy one is called bonding molecular orbital, and higher energy one is called an anti-bonding molecular orbital. Okay, and you can see molecular orbital diagram. If it is for more than 15 to 20 electrons, How many I have to memorize it? Yes, you can. Avanika Rao, you can see here energies of molecular orbital diagram. It is given as sigma 1s is less than sigma star 1s is less than sigma 2s is less than sigma star 2s is less than sigma 2pz is coming first, and pi 2px and pi 2py is coming next, and pi star 2px and pi star 2py and sigma star 2pz. So, only difference you are going to get it here, right? And now see, this is the p orbital contribution, 2px and py and pz and 2px and py and pz and combined to gives rise, and here it is given clearly. So, sigma 2pz pehle aana hai, pi 2px, pi 2py little more energy, pi star 2px and pi star 2py, then highest is going to be sigma 2pz. So, my question is, do we have to memorize all the way? Just if you memorize this, ye kafi badhiya. Okay, children? Any doubt? Avinika Rao, Anjana Pal, Anjana Pal. Okay, thank you very much for your patience, and you can see features of molecular orbital theory. This is a very important point. Feature 5. So far 4 features we have seen, and again I am coming to the feature 4. Orbitals are filled according to Aufbau rule. What is Aufbau rule? Electrons filled in the orbital in increasing order of the energies. And what is Hund's rule? While you filling the degenerate orbitals, the orbitals has to be half filled, then only pairing takes place with opposite spined electrons. And what is the Pauli's exclusion principle? It says an orbital can have maximum of 2 electrons with opposite spin. So, it says no 2 electrons in an atom can have a same set of 4 quantum numbers. So, these are the things you should develop a lot of confidence in your mindset better. Right? Okay, anyways, bond order. So, the bond order is the number of bonding electrons plus number of antibonding minus number of antibonding electrons divided by 2. Maybe this looks little confusion, okay. So, bond order is equal to number of electrons in bonding molecular orbital minus number of electrons in anti-bonding molecular orbitals by 2. If the bond order can tell you many things, if bond order is 0, you can say there is no bond between 2 atoms. The bond order is 1, single bond exists. If bond order is 2, double bond exists. Bond order is 3, triple bond exists. Bond order can be fractional also. And if negative bond order, you cannot get it. And you can see the existence of a molecule. If bond order, it can be, look at here, 0 or it can be negative. Negative, you did wrong, 0 do not exist. Such kind of things, the molecule never and ever exist. Bacho, the presentations are made in such a way that you should have a clear picture based on this. Okay, let's talk about the bond order. If you take hydrogen electronic configuration, I just want to talk about the formation of hydrogen molecule. So, it has 1s 1 electrons. So, hydrogen molecule has 2 electrons. Simply write the electronic configuration sigma 1s2, sigma star 1 as 0. If that is the case, bond order is going to be half into Nb minus Na. It is going to 2 minus 0 into half is equal to 1. It is going to be a single bond exists between 2 hydrogen atoms in the hydrogen molecule. And also you can see this is the bond order one, and also you can say oxygen. You have oxygen 1s2, 2s2, 2p4. When you talk about oxygen molecule, 16 electrons. So, the electronic configuration of these 16 electrons, it means it is the next configuration you have to write. It comes to be sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2 and pi 2px2 and pi 2py2 and pi star 2p x1, pi star 2p y1. Why? Because they are degenerate orbitals. When they are degenerate orbitals, you have to follow the Hund's rule. While you follow the Hund's rule, you are going to have unpaired electron. Because of these unpaired electrons in the electronic configuration, oxygen is going to have the paramagnetic behavior. Oxygen is going to be paramagnetic. Oxygen is going to have paramagnetic. What is the meaning of paramagnetic, bacho? If that substance is placed in the magnetic field, there will be a deflection in the magnetic field. That is called as a paramagnetic substance. Okay. Now, bond order is going to be 2 as you calculated here. Any doubt? That's good. Now, let's talk about. So, nitrogen, it is going to have 1s2, 2s2, 2p3, it has a 14 electrons. So, this 14 electrons configuration is written like this. It is written like this: sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, pi 2px2, pi 2py2, and sigma star sigma 2py2. So, in that case, you are going to have the bond order 3, and it is going to be a diamagnetic. How do you calculate magnetic moment, everybody? How do you calculate diamagnetic? Deepika Naidu, Avanik, okay. So, I will show you that also. Nitrogen to nitrogen double bond is seen. And also, you can see the molecular orbital diagram of C2 molecule. Carbon has 6 electrons and it is going to 1s2, 2s2, 2p2. है ना? So, C2 molecule is going to be 6 plus 6 is equal to 12 electrons. So, the 12 electrons are written like this. In this electronic configuration, and you are going to see the formation. What is the bond order of He2 plus? Everybody, He, tell me, He, you tell me, He2. You are going to have 0 bond order. So, here bond order here, He has 2 electrons now, and He2 contain 2 plus 2 is equal to 4 electron. So, 4 electron molecular orbital configuration is going to be sigma 1s2, sigma star 1s2. So, the bond order is going to be number of electron bonding molecular orbital, anti-bonding molecular orbital by 2. It is going to be without star there are 2 electrons, with star there are 2 electrons by 2 is going to be 0. Therefore, He2 doesn't exist. He2 doesn't exist. When He2 doesn't exist, you can say which of the following can exist, which of the following cannot exist. You can see in the NEET examination, He2 doesn't exist. Assertion, reason its bond order is 0, or reason the number of bonded electrons is equal to number of anti-bonding electrons. So, you have various kinds of versions are there here, okay. And also bond order stability of the molecule is very, very important, and it is a noteworthy point. You can write bond order can tell you 4 important things here, and one is you are going to say bond order, bond strength directly proportional. More the bond order and the stronger is the bond, bacho. And more is the bond order, more is the stability of the molecule also. And also more is the bond order and bond length is going to be longer, shorter. So, as bond order is increasing, the bond length is going to be decreased and vice versa. And also, if the bond is more strong, bond dissociation energy is going to be more. So, I want to say the bond order is related to 4 parameters here: bond strength, bond stability, and bond dissociation energy. You can say it is the bond energy and the bond length, and existence and non-existence, and the stability and everything. You understand? And also, HOMO and LUMO, that is very important. HOMO means highest occupied molecular orbital, and LUMO means lowest unoccupied molecular orbital. Okay. So let us talk about what this HOMO and LUMO says. And this HOMO and LUMO, when you take an example, C2 molecule, you can say, this is the electronic configuration of C2 molecule. In this C2 molecule, you can have HOMO. These are the highest occupied molecular orbital. Okay, and these are, you can say, lowest occupied molecular or unoccupied molecular orbital. So this visual interpretations can show you what is what and how is going on, right? Dear children, Anvika Rao, Avnik Rao, Anjana and Naidu is there in the right now class. Please take a note of this, and how many HOMOs are there, LUMOs are there, and how they are interacting, you can say this. And bond order and the stabilities of the molecule. Bond order and the stabilities of the molecule. You can see the beautiful animation here. You can see the beautiful animation. Bond order can tells you lot of things here. It tells you the bond order is telling you the bond strength. As the value of the bond order increases, bond is going to be more stronger, and the value of the bond order increases, stability also increases. If the value of the bond order increases, bond length is going to be decreases, and the value of the bond order increases, bond dissociation enthalpy also increases. Bond energy. What is the meaning of bond dissociation energy? You all tell me. You all tell me. Yes. It is going to be the amount of energy required to break 1 mole of bond into its gaseous constituent atoms is called as bond dissociation energy. Okay, so we connect with the thermodynamics as well. Stay tuned to the channel so that we can discuss the things with more precise way, and also unpaired electrons as a dipole and the magnetic moment. So unpaired electrons acting as a magnetic dipole. So the magnetic moment of this given molecule can be done by using is equal to root over n into n plus 2. Here n stands for number of unpaired electrons in the given molecular orbital configuration, my dear children. Okay, if n value is 0, mu value will be 0. If n is equal to 0, then mu is equal to 0. Such substances are said to be diamagnetic. If n value is not equal to 0, mu value is not equal to 0, greater than 0 hoga, it is said to be paramagnetic. If it is a paramagnetic, it will be attracted towards the magnetic field. If it is diamagnetic, it will not be attracted towards the magnetic field. Okay, you can see the bond order can be explained on the basis of this. Bond order is the half into Nb minus Na. Okay, the bond order corresponds to the number of bonds. It could be 0 or fractional or an integer. Okay, and you can see since the electrons in the orbitals of Nb increases, stability of the molecules also decreases. Okay, if the electron number bonding orbital electron number increases, stability increases. Number of electrons in anti-bonding molecular orbital increases, stability decreases. That is a key noteworthy point. When you form ion, you have to remove the electron from the anti-bonding molecular orbital, so the highest energy orbitals. That is also very important. And if Nb is greater than Na, then the molecule is stable, it is rule. And if Nb is less than Na, the molecule is unstable. If the Nb is equal to Na, the molecule is also unstable, may exist or may not exist. Understand? And moving ahead, what we can do after this, we will do some questions. So this is due to the fact that anti-bonding effect, it is called anti-bonding effect, is some of the stronger than the bonding orbitals. Okay, and you can see, bacho, bond order is equal to of Nb minus Na. Stability of the molecule is directly proportional to the bond order. Dissociation energy is directly proportional to bond order, I already mentioned, and bond length inversely proportional to bond order. Okay, if all the electrons in the molecule are paired, the substance is diamagnetic. Any unpaired electrons are there, the substance is going to be the paramagnetic. You can say the carbon monoxide. Carbon has how many electrons, bachcho? We know that carbon has 8 electrons, oxygen has 8 electrons, carbon has 6 electrons, total is going to be 14 electrons. These 14 electrons are written in this way. Why Kk is coming? K shell, and it is going to have sigma 1s and sigma star 1s is completely filled. Okay, and you can say the bond order is going to be 3, therefore carbon monoxide, carbon and oxygen बीच में 3 bonds रहना है. Understand? You can say, I just want to give you a super awesome trick for everybody. Everybody who are online, please take a pen and paper and write this trick. You need not have to write the total electronic configuration. Simply write the configuration like this. Total number of electrons, dekho. Total number of electrons, you can say, simply write 9 to 20. Simply write 0.5. And add 0.5, 0.5, 0.5, 0.5, 0.5, it is going to have maximum up to 3, maximum up to 3.0. बाद में 0.5 decrease करना है 0 तक. That is the way you have to memorize this trick. बच्चों, this is a super trick. This is a super trick. Now you can say in the previous example, carbon monoxide. Carbon monoxide. So carbon monoxide, you see, carbon and oxygen, it has 6 electrons, 8 electrons, total 14 electrons. Na? If it is a 14 electrons, you can say bond order is going to be 3. We discussed this, bond order is going to be 3. You need not have to do this much work. Agree? And you want to do something like oxygen. Something like oxygen. Oxygen plus oxygen 2 plus and oxygen minus, oxygen 2 minus. Now, how many electrons are there in the oxygen? You can say 16 electrons, 15 electrons, 14 electrons and 17 electrons and 18 electrons. 16 electrons now I have the bond order 2.0. and 15 electrons now bond order 2.5 and O2 2 plus now 14 electrons is going to be 3.0 and it is going to be 17 electrons now 1.5 and it is going to be 1.0. So bond order gives you order of stability. So इसमें order of stability कौन सा होगा बेटा? Order of stability O2 2 plus is more stable than O2 plus stability. Stability O2 2 plus is more stable than O2 plus is more stable than O2 is going to be more stable than minus O2 2 minus. Yes, you can see this is a famous question even from the NCERT text we can get it. Got it beta? Clear? Any doubt? And we'll do some questions based on this. Are you ready? We'll do some questions based on this. Now let's see here, nitric oxide. उसमें कितने electrons हैं? 7 electrons. उसमें कितने electrons हैं? 8 electrons. Total 15 electrons. है ना? If it is a 15 electrons, you are going to have 2.5 bond order. It is going to have bond order is going to be 2.5. That's it. And you can write this 15 electrons and you have the bond order is 2.5. इतना खर्चा करना है. But you can use my trick. Use a trick. Time बचेगा. Time game. NEET examination is a time game. You will be starved during examination. You require this time. So you're going to write 180 questions in 3 hours. Okay. So any doubt, please. Hope this trick is useful to you. Everybody take a screenshot of this. Screenshot of this. 3, 2, 1, click. Jaldi, make it fast. 3, 2, 1, click. Clicked it? Yeah. So those who are there in the line live, please like the button, like the session, share with your friends and subscribe to Infinity Learn NEET YouTube channel. And you please ask any doubt by using this chat box. You can use this if you have any doubts. Okay. Now talking about more questions. Which of the following is diamagnetic? Odd electron वाला का निकालना. Which of the following is diamagnetic? It has 16 electrons, it has 15 electrons, and it has 17 electrons, it has 18 electrons. Now you have it is the totally all electrons are filled. So you don't have any unpaired electrons. Sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, and sigma 2p z2, pi 2p x2, pi 2p y2, pi star 2p x2, pi star 2p y2. So where is the unpaired electron? Where is the unpaired electrons? That is the reason why it is going to be diamagnetic. So no unpaired electron. So no magnetic moment. So that diamagnetic is going to be n is equal to 0, mu is equal to 0. Understand? Now one more question, beta. Decreasing order of the stability. Decreasing order of stability. Just we did it now. It is bond order is going to be 2. It is going to be 1.5. It is going to be 2.5. It is going to be 1.0. So this is going to be C. Simple. Bond order is directly proportional to the stability. Bond order is going to be directly proportional to the stability. Bachcho. And you can see, according to molecular orbital theory, correct order of increasing bond orders. Okay. So here it is going to give you the nitrogen, n nitrogen plus minus 2 minus. So it has a 14 electrons, it has a 15 electrons, it is going to be 16 electrons. Dear children, 14 electrons, you can see the trick, 14 electrons you have 3.0, 15 2.5, 16 2.0. So you apply the same thing here, So 14 electrons bond order is going to be 3.0, and 15 electrons bond order is going to be 2.5, and 16 electron bond order is going to be 2.0. So you can say the increasing bond orders. So nitrogen is greater than N2 minus greater than N2 plus. Are you getting or not? So here nitrogen greater than N2 minus greater than N2 2 minus. Are you getting or not? Clear? Any doubt? This is the answer for this question. Clear? Okay, get ready. We'll do one more question. Now arrange the following compounds in increasing order of OO bond length. It is somehow more complicated, looking like a complicated. Here it is going to have, children, here you can see it is O2 and it is going to be O2 plus. It is going to be O2 plus. Here going to be KO2. Okay. So it is going to be, it is also O2 plus. Okay. K plus O2 minus, both. K, you can also say K2 O2, better you write as a K2 O2. So O2 2 minus. Okay. Now the bond orders. So it is going to be, bond order is going to be 2. Okay. Bond order is going to be 2.5. bond order is going to be 1.0. So you know bond order and bond length, how they are related. Bond length is inversely related to bond length, इनवर्सली रिलेटेड टू बॉन्ड ऑर्डर. जिसका बॉन्ड ऑर्डर ज़्यादा है उसका बॉन्ड लेंथ कम होगा. सो द इंक्रीजिंग ऑर्डर ऑफ द बॉन्ड और लेंथ. सो बॉन्ड ऑर्डर इज गोइंग टू बी O2 is greater than and O2 2 minus. Okay. So bond length O2 plus less than O2 less than O2 2 minus. This is the order. So in the NEET examination, that twist will be there. That twist will be there. You have to follow the twist and you have to unfold the twist. Like that, you can do the best of this molecular orbital theory. In today's class, we discussed about what is a molecular orbital theory, how molecular orbitals are formed by linear combination of atomic orbitals, and I have given you the molecular energy diagrams where you can say LUMO and HOMO, and how to write the electronic configuration. I mentioned how to give the tricks to crack the NEET examination, and we did some sample questions as well. Yeah, Kaiser, you like the session? How do you feel? You understand the questions, right? You understand the concept? Kaiser, you please like the session. Everybody, please like the session and share with your friends and subscribe to NEET Infinity Learn YouTube channel. And we are done from our side. Thank you. Very easy. I have given you the very easy tricks as well, right? So, Kaiser, और एक बार like button दबाना. So, before I sign off, I want to see the number of likes in the session as well. Kaiser, you enjoyed the session? Okay. So, we'll meet with, I am repeating NEET. Of course, that's good. Congratulations. And you subscribe to the channel so that we can understand all the important concepts that are related to the NEET examination will be discussed in this NEET YouTube channel, and you are going to get the best out of it. Okay, thank you. We are done from our side. Signing off, Suresh, Faculty of Chemistry from Infinity Learn YouTube studio. Thank you very much. Thank you.